Now let's put our new skills to work to perform an exercise. Sound loudness is measured in decibels. We're going to write some code to output a characterization of a sound based on the levels in the following table. For example, if the decibel level is 50 or less, then the characterization is quiet. If it's greater than 50 but less than or equal to 70, then it's intrusive. If it is greater than 70 but less than or equal to 90, it's annoying, and 3 other categories. Let's go ahead and start writing our code. First, I'll create a variable, d, to hold a value. I'll initially set it equal to 25. Now let's take care of the first condition. If d is less than or equal to 50, then we'll output that the noise is quiet. Console.log quiet. We could write an if statement, a separate if statement here, but since each one of these exactly one of these categories will be printed, let's go ahead and write an else if statement. Else if d is strictly greater than 50, and, so use ampersand ampersand, d is less than or equal to 70, we'll print out intrusive. Let's go ahead and test our code before we continue with the rest of it. Executing this code with d equals 50 means that the first one will execute, and it'll print quiet. If d is 60, then the second one will execute, intrusive. If it's strictly greater than 70, we haven't written those conditions yet, so we would expect nothing to happen, and it doesn't. Before we write the rest of the conditions, though, let's make an observation about that else if statement. The condition here will never even be evaluated if the first condition holds. In other words, when d is 25, d is less than or equal to 50 will be satisfied, it'll evaluate to true, and the console will print out quiet. The second condition will never even be checked. So in one sense, the checking for whether or not d is strictly greater than 50 is completely unnecessary. This is known as fall through. We can go ahead and get rid of that first condition entirely if we want to. And it will have the same result. Quiet, intrusive, and greater than 70. We haven't written that code yet. Let's continue writing the rest of the code, but with this simplified statement instead. Else if d is less than or equal to 90, the third threshold here, the noise is characterized as annoying. For the last condition, when d exceeds 130, we can just include an else statement, because all other values are taken care of by the logic above. All values less than or equal to 50 are taken care of by the first one, and each subsequent check takes care of a range of values. So the last one, we only need an else statement. Let's go ahead and test it out on a range of values now. For 80, we would expect annoying. For a value of 105, we would expect very annoying. For a value of 125, medical threat, and for any value larger, say 1000, it would be caught by the last else statement.